In this section, we're going to be simplifying rational expressions. So we're going to go ahead and look at an example. Here we have 5 divided by 8r. What we want to do is we want to find an excluded value of each rational expression. So basically an excluded value is a number that's going to make the denominator equal 0. So what you want to do is you want to set the denominator equal to 0. So we want to go ahead and set 8r equals 0. And then isolate r and solve for r basically. So you want to divide both sides by 8. So 8r divided by 8 would leave us with r, and 0 divided by 8 would leave us with 0. So the excluded value is 0. Because if you plugged in 0, you would have a 0 on the denominator. Now we're going to look at another example of this. We have 9d plus 1, d squared minus 2d. And we want to find the excluded value again. So remember, you want to set the denominator equal to 0. So d squared minus 2d equals 0. And we can go ahead and factor out a d because both terms have at least one d. So that would give us d, parentheses, d minus 2 equals 0. And then you want to set each term individually equal to 0. So d equals 0, and then d minus 2 equals 0. And when d equals 0, it just equals 0. And then d minus 2 equals 0. You got to add 2 to both sides in order to isolate the d. That gives us d equals 2. So the excluded values are 0 and 2, because if you plugged in 0 or 2 into the original equation, you would get an undefined answer, and you would get 0 in the denominator. Now we're going to look at an example of simplifying rational expressions. Here we have 3t cubed divided by 12t. So we can go ahead and break down the denominator into 3 times 4t, because 3 times 4 equals 12. So we can see that we have a 3 at the top and a 3 at the bottom. So we can go ahead and cancel both those out, and we have t3 at the top and 1t at the bottom. So we can cancel out 1t at the bottom and 1t at the top. So that would leave us with t squared over 4. And that would be the simplified version of it. Now we're going to look at another example of simplifying rational expressions with trinomials. So we have the problem k plus 1 divided by k squared minus 4k minus 5. So we're going to write the equation k plus 1 divided by k squared minus 4k minus 5. And what you want to do is you want to start by factoring the denominator. So we can see that we have a trinomial, and we want to look at the factors of negative 5 that add up to negative 4. So if we look at negative 5 times 1, negative 5 times positive 1 equals negative 5, and negative 5 plus positive 1 equals negative 4. So those are the factors we're going to be using. And because it's just a k squared with no number in front, we can just put k at the beginning of both parentheses. So we have k plus 1 divided by k plus 1 times k minus 5. And we can see that we have a k plus 1 both in the numerator and denominator, so we can go ahead and cancel them out, leaving us with 1 over k minus 5. The 1 basically comes from k plus 1 divided by k plus 1 equals 1. Now we're going to look at another example. This time we're going to be simplifying rational expressions using opposite binomials. Here we have 2x minus 10 divided by 25 minus x squared. So what we want to do for the top is we want to pull out the 2, factor out the 2 basically. So if we factor out a 2 on the first 2x, we'd be left with x, and then if we take out a 2 on the 10, we'll be left with a 5. And then if you look at the bottom, it looks like a square of differences, a difference of squares. So if we pulled out a negative from the bottom, we would have negative 1 parentheses x squared minus 25. Now that x squared minus 25 looks a lot like the difference of squares that we've done in previous sections. So we know that simplifies out to x minus 5 times x plus 5. So now we can go ahead and rewrite our equation. We have 2 parentheses x minus 5 all over negative 1 parentheses x minus 5 parentheses x plus 5. So the x minus 5 and the x minus 5, both in the numerator and denominator, can cancel out. So we have 2 over negative 1 times x plus 5. And we can go ahead and distribute that negative 1 if we want, leaving us with 2 over negative 5 minus x.